What is the cosmic microwave background radiation? Where does it come from? How was it discovered? What are the implications of its discovery to our understanding of the universe? We'll answer these questions in this short video as we explore the wonders of the cosmos in which we exist.
Our current understanding of the universe revolves around a model widely referred to as the Big Bang. Under this model, cosmologists are able to extrapolate how the universe developed in its early stages all the way back to 10 to the negative 43 seconds after the beginning of space and time.
From this moment through the first 5 minutes of the universe's life, the universe underwent multiple tremendous changes in its state of existence. For example, the three quantum forces of nature, the strong nuclear, weak nuclear, and electromagnetic, split from a unified force into separate forces. Also, the universe underwent a dramatic instant of expansion called inflation. The universe cooled from about 10 to the 32 degrees Kelvin to just 10 to the 9, and almost all of the hydrogen and helium in the universe, which make up more than 99% of the matter currently in existence, was formed during this time.
From this time into a few 100,000 years later, the universe was filled with a plasma that consisted of hydrogen and helium nuclei, and free electrons that scattered photons of light such that no matter could be observed. Fast forward to about 380,000 years later, after the Big Bang, and the universe had finally cooled sufficiently to allow the previous free electrons to attach to the atoms of hydrogen and helium. This event, referred to as recombination, allowed photons to finally roam freely. The universe, for the first time ever, became transparent.
The development of the early universe just described, or in other words, the Big Bang model itself, implies a radiation present throughout the entire universe that should currently be detectable as microwaves. This radiation was first predicted by George Gamow, Ralph Alpher, and Robert Herman in the late 1940s, and was later discovered accidentally by Arno Penzias and Robert Wilson. It is known today as the cosmic microwave background radiation.
The universe began with a bang, but how do we know? Multiple factors, including the following, serve as evidence that favors the Big Bang model. The universe is homogeneous and isotropic. The universe is expanding, and the matter in the universe consists of about 74% hydrogen and 25% helium.
A fourth factor, the piece of evidence that is our topic of discussion in this video, is the radiation present throughout the entire universe that has a blackbody temperature of about 2.7 degrees Kelvin. This radiation is known as the cosmic microwave background radiation, and its discovery emerged by accident following the exciting series of events which we will describe now.
Arno Penzias and Robert Wilson were radio astronomers hired in the 1960s to conduct research at Bell Laboratories on microwave signals from the spaces between galaxies. In order to conduct their research accurately, they needed to eliminate any microwave static coming from interfering sources to avoid the obscuring of their observations.
The scientists encountered an incessant static sound coming from all directions towards which they faced their microwave detector. First, they thought it might be coming from nearby New York City, but found it was not due to urban interference. They were also able to rule out the possibility of the interference coming from within our galaxy or from an extraterrestrial radio source.
They next hypothesized that the interference may be the result of excrement from pigeons that were nesting within the device's antenna. They built a trap to lure the pigeons out, then spent hours cleaning the invasive feces. Unfortunately, after all of their cleaning, the incessant static interference prevailed.
Around the same time, Robert Dicke was conducting research at Princeton University trying to find the cosmic microwave background radiation predicted by the Big Bang model. Penzias and Wilson heard about his research and reached out to his laboratory to discuss the possibility that the interference was in fact coming from the radiation that Dicke was trying to discover. A visit by Dicke to Bell Laboratories confirmed that what Penzias and Wilson had found was in fact the cosmic microwave background radiation.
The two groups published their findings simultaneously in astrophysical journal letters. This final piece of evidence led to widespread acceptance of the Big Bang model of the universe. Penzias and Wilson later won the Nobel Prize for Physics in 1978 for their serendipitous discovery.